good. Thanks everyone for coming out today on this wonderful rainy evening. Hope you enjoyed the pizza and drinks. This topic today is, as you can see here, automating disaster recovery using Cloudwatch alarms. So this technique can mainly be used for legacy-based systems where high availability isn't really an option. Sorry, it's not about Gen AI, so it's quite the opposite. It's based on legacy stuff, so we're going way back. The presentation probably won't be too long. It's pretty simple and easier to follow demo as well. Can get back to chats pretty quickly after this probably. And I'd like to keep it informal, so feel free to ask questions at any time. That's cool with me. Cool, so I'll go ahead and kick it off, I suppose. So if I go just over who I am, so that's me, I'm Jeff. I'm Solutions Architect at CyberCX. It's a cyber security company. Myself, I'm more focused in the cloud solutions team. So heavily based on AWS especially, so we've got multi-cloud, but myself, I'm in the AWS department. So I'm an ambassador as well as a community builder. I would heavily encourage everyone here to look into those programs. They're really cool and really good communities. Quite a few benefits as well, such as free credit, swag, certification, vouchers, that kind of thing. I come from a background of full stack software development and in the commercial experience with health and fintech. But I gradually became more immersed into DevOps and the world of AWS. So these days, I mainly help organizations deliver secure AWS solutions using best practice. So just helping them implement whatever they need to into AWS. So that's just a quick introduction of who I am. So this meme kind of sums up what this presentation is about. So it's not that easy to make legacy systems highly available in a lot of cases. There's a lot of hard dependencies, things like how you can only have single nodes, they're very stateful applications. They might also rely on static IPs that need to stay the same, which means that you can't split it across more than one node. So this is just going to go through a method that you can use in AWS to make your system easily disaster recoverable so that you're effectively making it highly available because you're minimizing your downtime. Just go over a few high-level sort of definitions. So just to go over what HA and DR is, so high availability versus disaster recovery. So high availability, that's eliminating single points of failure. So you're introducing redundancy into your systems. That basically means that when a resource fails, there's always something there to take its place. So kind of like a Hydra, if we want to sort of give it a physical analogy. Disaster recovery on the other hand, so that picks up where high availability isn't possible. So it can be as simple as restoring from a backup or failing over to another environment. So that depends on two main concepts. We've got recovery time objective and recovery points objective. So recovery time objective, as a lot of you might already know, is the maximum acceptable amount of time that a system can be down, and recovery points objective is the maximum acceptable loss of data. So those are very key sort of concepts in disaster recovery. So this is just a diagram of very simple one about what I'm going to present in the demo as well. So HA, as you can see there, we've got two concurrent nodes pointed to by a load balancer. So both nodes, both instances are able to serve requests at the same time. DR, on the other hand, that's more about failing over because only one node is able to support a legacy-based application especially. So very simple diagram there. So high availability on legacy systems. So there's a few limitations that can make that a very difficult thing to implement. And that's mainly due to a few factors. So basically to begin with, a legacy system, what it is in this definition is an outdated solution. So still in use, but it's necessary to meet the needs of what it was designed for. Growth and innovation is limited. That's usually due to how it's been implemented. So maybe it depends, as I mentioned before, on static IPs. It's a very stateful system, so you can't have stateless transactions going into it. So that's what a very common thing of a legacy system is. And yeah, very monolithic in nature. So everything is just on one node basically for a lot of these systems. And yeah, so basically the nodes in legacy systems, they commonly need to be managed as pets rather than cattle. So that's another DevOps kind of terminology. So pets, they're called pets because we care about them. You name your pets, you feed it. You want to make sure that it stays up and alive, whereas cattle, that's more expendable. So that's for non-legacy systems. We don't really care that much about cattle. We raise them to our benefit to consume. But maybe that's sort of an outdated analogy if you're a vegan. So, but yeah, I won't go further into that. So yeah, so basically legacy systems, they're pets more rather than cattle. So cool. So this is basically the architecture pattern of what I'm going to go over in the demo. So we've got a Cloudwatch alarm, and that gets triggered based on a health check. So the health check that we're using in this presentation, this demo, is a system failure. So that could be an AZ outage or a power failure in the availability zone, for example. Anything that is on the AWS side of things that they're responsible for. And the next step that we do when the alarm is triggered is that we're triggering a Lambda function. And this particular Lambda function is doing 4 steps. So the first one is we're starting the disaster recovery instance. So that's the failover. And then the next is we're associating the same elastic IPs that are on the original main instance that was up to the disaster recovery instance, because that's the instance that we want to switch to. And then next is we're optionally running some SQL to change the database state, just in case there's some data in the database that relies on a certain state of IPs. So we've found that that's quite common in a few clients that we deal with. And then finally, we're just setting the listener weights on the load balancer to point to the disaster recovery instance. So yeah, quite a simple sort of steps to follow, and I can show in the demo how that looks like as well. And just to reiterate, this is for disaster recovery of the compute aspect. So what we've found in legacy applications is that the storage usually is able to be highly available just because it doesn't have those same limitations that compute does, where it needs to have single nodes. The storage usually is available on a single endpoint that you're able to access that can be highly available. If that's not the case, maybe your legacy system is that outdated that you do need to have a failover, the same concepts can be applied as well to storage. Cool. So just to go over the basics of the Cloudwatch alarm that we're going to use in this demo. So there's 2 different statuses you can have on EC2 instances. We've got system status, so that monitors the AWS systems in which your instance runs. So as I mentioned, it detects problems with the underlying hardware in the AWS availability zones or data centers. So that could be an AZ outage or a host outage, any physical issues. It's not restricted to specifically an availability zone outage, but just any physical issues that happens on the AWS side. Instance status, on the other hand, that's monitoring things like software and network configuration of the individual instance. So that typically requires your involvement to actually repair. So it could be incorrect network setup on the instance, or that's some sort of startup config. Maybe you've exhausted the resources such as memory or CPU on the system. So this particular demo, we're going to use system status as the alarm, which is also a health check, as a Cloudwatch alarm that triggers the triggers the failover to the disaster recovery instance. Cool. So from here, I guess we can just go straight into the demo. So I'll just go ahead and bring up the sandbox environment. So yep, so this is my sandbox environment. I've got a few components to it. Sorry, this is the Cloudwatch alarm. So as you can see here, that status check failed. So that's triggered whenever the system status check failed is triggered as an alarm on the main instance. And I've also got the alarm for the disaster recovery instance as well, so that you can switch back depending on which instance fails. And if we go into the actions of this particular alarm, as you can see here, there's two actions. First of all, I get notified to an SNS topic. So that means I get an email notification on when the system has actually failed. But more importantly is the second action, which invokes the Lambda failover function, which does all of those 5 steps that I presented earlier. Cool. And I'll go through a few of the other components. So this is the load balancer. So 2 separate target groups, one pointing to the main instance. There's 0% going to the disaster recovery because that's not up yet. So it's currently stopped. So that's the DR instance. As you can see there, it's stopped at the moment because it's not active. We're pointing to the main instance. So that's, oh, yeah, sorry. Just have to go there. Yep, so that's the main instance. It's running. So that's the one that is serving all requests at the moment. So as you can see there, it's running, and these are all of the elastic IPs that assign to it. So those are static IPs that a lot of legacy systems need to actually run, and yeah, so that's what's attached to this particular instance. And then we've got the Lambda function. So this is the stuff where all the magic happens, really. So this is what gets triggered whenever the system fails, and it does all of those actions to do the failover. So I can sort of go through a bit of the code. I can actually link all of this example code as well into the meetup group after this presentation. So yeah, I'll go ahead and do that as well if you want to refer to it. But basically what it does is there's, as I mentioned, a few actions here. We've got, it's starting the failover instance, then it's associating the elastic IPs, oh sorry, back here, yeah, it's associating the elastic IPs. You can also run some optional SQL on the failover, and then finally it's setting the listener weight so that it points to the disaster recovery instance. Cool, so this is the link for the ALB. As you can see, it's not secure because I haven't actually used a proper certificate. This is just for demo purposes. So yeah, I'll just go ahead and show you. So I reload, this is pointing to the main instance. I just customized the index.html page to show that. So it's just running Nginx, very basic sort of thing going on. Cool, so what I'm gonna do to simulate a failover now is I'm going to trigger this particular alarm. So when I trigger this alarm, I should see those 4 steps happen, which I mentioned before. So those are the 4 steps of, if I bring back the other slide just to refresh everyone. So it's going to start the disaster recovery instance, then it's going to associate the elastic IPs to the disaster recovery instance. I'm not changing any SQL, but that's just an optional thing. Finally, it's going to set the listener weights to point to the disaster recovery target. Cool, so if I go back to the demo, and sorry, it's a bit of switching around here. It's this one here, cool. So what I'm gonna do is I'm gonna run a command in Cloud Shell. There's a very handy shell within the AWS console that you can use to run commands using the AWS API, AWS command line. So if I go ahead and I've just copied this command from before. So what this does here, I'll enlarge it a bit so you can see. That's basically setting the state of the alarm to be in the alarm state. So that's simulating a system failure. So once I run this, I'll show you what's going to happen. So I'll go ahead and just make sure that's the right one. Yep, so I'll go ahead and enter that in. Cool, so now that's run. So I should see that this instance stopped, but it's going to start now. Yep, so I can see it's running. And I can also see that slowly the elastic IPs should be assigned to it. Yep, see, it's starting to come in. So that's cool, that's working. Cool, so that's all assigned. And then I should also see that the load balancer is currently 100% on the main one, but it should have switched to the disaster recovery instance as 100%. Yep, I can see that switch. So if I refresh this page, I should see that it's now pointing to, as you can see, the failover instance. And similarly, I've got another alarm for the disaster recovery instance, which is in the other availability zone. So if I go ahead and run that one, as you can see here, it's referring to the disaster recovery status check. So I'll go ahead and run that. It should fail back to the main instance. So yep, I'll go ahead and run that. And if I go back here, I should see that the elastic IPs now get assigned back to this one. Yep. And then if I go to load balancer, it should change from 100% to the other one. Yep, so that's now 100%. And if I refresh this, it should point back to the main instance. Yeah, cool. So yeah, I can show there that's a working sort of pattern to fail over for legacy-based systems, which really depend on those static IPs. Cool. So that was a quick demo on how that works. So that was very basic sort of stuff. It's something that anyone can implement. I can release the code into the chat as I mentioned as well. Yeah, so very short presentation actually. So in conclusion, so this pattern, it can be extended to use triggers for other types if necessary. So say for example, if you've got a more accurate health check that you want to use to trigger the failover, there's things like Cloudwatch synthetics, which have a health check on a certain URL. You can use that to trigger the Lambda function, which does all of these switches. Second point is that failover operations, they may not work if they rely on the control plane to be operational in the availability zone that's affected. So what this means is that the operations that I'm using in this one, things like switching over EIPs, changing the target groups, they're not dependent on the availability zone, so that's why those work. But if you do operations that are dependent on an AZ being up, then they may not work. And finally, as a warning, if you make a legacy system more resilient, it might decrease the drive to decommission them. I've experienced this in the past as an application developer in a previous life. We made what we called tactical solutions at the time, was supposed to be temporary solutions to solve temporary problems. The business, though, they never were motivated enough to decommission them because they just found that it was fit for purpose, but it just meant that we had to keep making changes to these temporary systems. So just as a warning, if you do improve legacy systems too much, it decreases the drive to decommission them from a business perspective. Cool. So that's basically it, really. So thanks, everyone, for listening. Is there any questions that anyone might have?
I have a question. Yep. So I think maybe for demonstration, you only demonstrate a simple thing, like almost like a static thing, doesn't have a transaction or the database involved. Like, yeah. I guess for maybe a transaction sort of process or session that needs to evolve. Is that like, is your pattern going to be evolved to be able to?
Yeah, you can put whatever you want in the pattern to as a failover operation. Just anything that you can implement using the AWS API. So for instance, it's using Lambda here. So whatever you can put into a Lambda function, you can simulate. So if I did want to fail over storage, for example, I could put an operation in there to fail over to the second storage endpoint. You can put whatever you want there. Again, as long as it doesn't rely on the control plane and the availability zone that went down. So, yep. Cool. Cool. I guess if there's no further questions, everyone can probably get back to the good chats that we were having then. So yeah, thanks everyone for listening.